Yesterday, I introduced the laws of thermodynamics. We know that energy can change forms. That's the first law. But when we do that, some of it always gets lost, gets put back in the system. That's the second law. That's efficiency. Can never be 100%. We want to apply that to productivity. Productivity is how much biomass is made through photosynthesis in an ecosystem. Got to get that energy from the sun. You've got a job, you get paid $7 an hour, and you get paid every 2 weeks, and you work 10 hours a week. How much money did you make? Your first paycheck. See, $140, that's correct. That's how much you earned. So your boss hands you your first paycheck. This is before direct deposit days. Your boss hands you your paycheck, and it is not $140, is it? They took some money out. We got to pay taxes so that you can have quality teachers in your public schools. The most important thing your tax money goes for is my salary. We got to have libraries and roads and firemen. So you don't make $140. They take some out. That is the difference between your gross pay and your net pay, right? You grossed $140. That's what you earned. But when they take some out for taxes, your net pay is what your actual paycheck would be. So make sure you understand those two terms. Gross is always bigger. Gross is greater. That's how I remember it. GR. Gross, greater, grop. Greater, gross, grop. Never mind. Okay, I showed you this slide yesterday. Said we'd come back to it. So this whole concept, gross primary productivity, GPP. GPP is how much energy is converted from the sun. How much sunlight through photosynthesis becomes an organic compound. First law of thermodynamics. But the plant also has to live. It has to be alive. And that process is called respiration. Isn't that cool? Plants do both. They do photosynthesis and respiration. And it takes some energy to respirate. So we have to subtract that. That's the taxes. Respiration is the taxes. Minus R. And that gives us the answer of how much energy is actually stored in the plant. Net primary productivity, that's the paycheck. GPP is net primary productivity plus R, plus respiration, the total amount of energy in the plant. Biomes can be measured by their productivity. And this is NPP, after we take out respiration. Remember that the most productive biome by area, the most productive biome by area is wetlands. The answer is always wetlands. Swamps and marshes in particular are the most productive per area. One of the lowest is open ocean. But if I showed you this chart and I showed you GPP, total on Earth, not by area, remember that open ocean is the most. Because the oceans cover so much of the planet, have so much surface area, they are the most productive. For terrestrial, it's tropical rainforest. That shouldn't be any surprise. If you got the most plants, you should have the most productivity occurring. All right, if the GPP for a patch of forest is 10, oh, look at that unit. They expect you to recognize the units too. Kilocalories, that's energy, per meter squared. In fact, when we measure productivity, we go out with a big grid, and it's usually a meter squared grid. And we lay it down and we literally count up how much primary producers are in that meter square. I'll show you pictures of that later on. So energy per meter squared, 10. The amount of respiration for that forest is 5 kilocalories per meter squared. So what is the NPP? There's our equation. We know NPP is going to be 10 minus 5 Don't forget to bring your units along. NPP of a wetland is 8,000 kilocalories per meter squared per year. The amount of respiration is 12,000 per year. What is the GPP? So this is an algebra question, right? We've got our equation. We can either rewrite the equation or we can plug the numbers in and solve it that way. But remember, GPP is just the total amount of energy that is produced. So we just add them together. 8,000 and 12,000 gives us the correct answer. We have two forests. They have equal amount of gross primary productivity. So roughly the same number of trees, same kind, same size. The NPP of forest A is 1650. And for forest B, it's 1110. So we need to read the statements and determine which one is true. Forest A has a higher rate of decomposition by bacteria. Does decomposition by bacteria have anything to do with productivity? No, that's dealing with dead stuff. Who cares? Forest A has more biodiversity. Even if that's true, that doesn't affect what we're trying to study. We already know that GPP is the same, so who cares? It's not B. C, forest A producers have lower rates of cellular respiration. That means we would subtract less, right? Did we subtract less from forest A? Yeah, because its value is higher. So C makes sense. Let's double check D just to make sure. Forest A producers have more biomass. No, we already said that they have the same. They have the same biomass. So the correct answer here was C. Two locations. It looks like on average, location 1 is much sunnier than location 2. More sun would equal more photosynthesis, right? So let's read through these. Gross primary productivity is the same for both locations. No way. No way would they be the same because the amount of sunlight does affect photosynthesis. Gross primary productivity in location 2 is greater than that in location 1 in December. Well, no, because location 1's getting more sunlight. Okay. Look at D, it's almost the exact same thing. Location 2 is greater in September. No, not quite. Okay, so it's got to be C, right? Gross primary productivity in location 1 is greater in March. Yes, in March, location 1 is getting more sunlight. So the correct answer, again, is C.